you can easily generate complex key codes and passwords using the masking generation mode, which in a nutshell allows you to use all the different building blocks together: characters, words, sequences, random numbers, and literals, mixing and manipulating them with built-in operators. This allows for unprecedented flexibility. And unlike other generation modes, the masking mode gives you full control over the placement of building blocks within a password. Such high level of control is achieved with the help of masks, which in essence specify the pattern for future key codes and passwords, outlining the order of individual building blocks and their relationship to one another. Let's now examine some features of the masking mode. We'll start with this simple mask, which produces the passwords of the following form: random word from built-in dictionary, capital letter A in the mask, followed by literal dash, followed by one random character from the numeric built-in character group, followed by two random characters from the uppercase built-in character group. Notice the output of the mask. Now let's change it a little bit by adding what's called random distribution operator and see what effect it has. As you can see, the individual building blocks of a password have been randomly distributed. And notice how the words are still preserved. Now, suppose we want to mix all the characters together. To do that, we have to use the random character distribution operator, which does exactly that. Now the words are no longer preserved and are totally unreadable. Now let's complicate our mask by adding a random hexadecimal number to it, and to do that we'll use the range operator. We'll use 16 as that is the base for hexadecimal numbers. We require 3 digits, and we'll start from say 0 to 999 and see which results we get. And sure enough, the properly formatted hexadecimal numbers appear in the right place just as per our mask. But what if we want this hexadecimal number to appear randomly either at the beginning or at the end of a password? Thanks to the random placement operator, this is possible. We've now modified our mask a bit for you to see how the random placement operator works. The A is simply a word taken from the built-in dictionary. These literals are nothing but spaces. And then the randomly generated hexadecimal number will simply be placed either at the beginning or at the end of this central password core. And just as we specified, it is placed either at the beginning or at the end of our password core. And notice how the random placement operator allows you to specify the entire masks as its input. We'll use the following example to better illustrate this. We've slightly modified our mask. Namely, we have changed the empty literal part with this. This is called random length operator. And in this case, it will generate anywhere from 1 to 4 randomly chosen uppercase characters. And the way it will work is that if the randomly generated 1 to 4 uppercase characters will be placed at the beginning of the password, then the other part, our random hexadecimal number, will be placed at the end, and vice versa. And look at the results. just as our mask specifies. If the hexadecimal number goes at the beginning, then the randomly generated random number of uppercase characters go at the end, and vice versa. Now we have covered most of the operators. It's worth mentioning the sequences feature, which is explained in more detail in the sequences demo. Take a look at this mask. This mask has a hexadecimal sequence, followed by a literal dash, followed by decimal sequence, followed by literal dash, then followed by 4 randomly chosen numeric characters. And take a look at the results. As you can see, the last 4 characters are randomly chosen numeric characters, just as our mask specifies. But the first and second part of the generated passwords represent sequentially adjusted numbers. The first part is hexadecimal, the second part is decimal, and you can easily specify all the properties you want for these sequences. For example, the number of digits they must have, the starting position, and so on. This demonstration has shown some relatively simple masks. However, your masks need not be that simple. In fact, there is no limit to how many building blocks a particular mask can contain. And moreover, different mask operators can be nested in one another. This will allow you to generate truly complex passwords and keycodes that strictly match your requirements.